Good evening, friends. I hope you're all doing well. I'm also fine. Today, I'm going to show you how you can create an elastic Kubernetes service in AWS. So, AWS has a managed Kubernetes service, which is called EKS. Using EKS, you can run your Kubernetes control panel and also node groups, nodes, etc. In this process, I'm going to use the EKS CTL or EKS Cuttle. So this is a tool that helps you to easily deploy a cluster or create new cluster in AWS with just writing few lines of code. So let's get started. I'm in the control panel of the EKS. At this moment, there is no cluster available. So what I'm going to do, I'm going to create a new cluster. Now, there are two ways you can manually create this, but there are some issues with manually creating. And those issues are especially creating those VPC, IAM roles, all those things. You might probably not follow properly. And then at some point, you will see something is not working. Probably you will spend hours and hours and hours and debugging what went wrong. And it's very hard to figure it out. Once you have find it, then you could have fixed it. But if you use the standard way of EKS-CTL, then they create all those IAM roles, IAM permissions, private VPC, private subnet, public subnet, all those things. And they also add those necessary tags because you need to add tags in the private or public subnet to work with properly. So I'm going to use EKS CTL, and I suggest you to use this tool as well for creating the cluster because it will reduce a lot of your headaches. So just use it. It will easily deploy your cluster, your node groups, assign 2 nodes, and all those things will be done. Once it is created, then you can modify it or install a lot of things here. So if you go to the eksctl.io and then go to introduction, then go to installation section, you will be seeing installations options here. So I'm going to choose the curl method. So just copy this command. And AWS has a shell. If you have seen this shell, Cloud Shell, you can use it for running all those necessary commands here. That's pretty useful, I suggest. If you do not want to install it on local machine, I have installed in my local machine, but if you don't want to install in local machine, you can use Cloud Shell. That is also helpful. So this loading. Takes some time. So just wait a few. Probably it's first time I'm coming to the Cloud Shell and it is setting up the environments. So taking some time. But once it is ready, you are good to go. It is kind of like a virtual desktop with only shell access available. It has all those power that you need as a Linux machine without the GUI feature. So it doesn't have the graphical user interface, but it has the GUI feature, and using this, we can easily run all those necessary commands inside your AWS network. So it's almost there. Yeah, here it is. So what I'm going to do is just copy this and paste it. It will ask you your confirmation. So what it does, it's going to download this file using curl and then install it. That's it. So let's verify EKS-CTL version. Okay, EKS-CTL version. Yeah, it is 0.122.0. Okay, that's good. Let me clear the screen. Let me check if I can make this screen a bit bigger. Maybe not. Okay. So the command is simple: EKS CTL create cluster. That's it. You don't need to specify anything else. That's it. It will use the current region that you are in. It is US-based one. It will auto-generate a name, and it will generate all those IAM roles, permissions, blah, blah, blah. It will also create a node group, also assign two nodes automatically. You don't have to assign anything. It's quite useful. There are a lot of pre-packaged library useful manifests available. If you go to examples, this is a GitHub repo, and using these examples, you can use any of the examples to create your cluster. For example, if you wanted to use spot instances, I highly recommend this using. You can use this manifest file and run this inside your shell. So what it does is it will use it will create a node group. Name of the node group is ng1, minimum size 2, maximum size 5. Then it will define the instance types, T3 small, T3 medium, and also it will say that spot instance pool 2. So you use the instances from the spot instances. The benefit of using spot instance is that it is very, very cheap. That means you can run a spot instance almost like 70% or 80% reduced rate compared to the on-demand instances. So this will take some time. Remember that it's not very fast. So usually if you do manually, that is also taking time because cluster creation, it is time-consuming thing, and also adding nodes, node groups, etc. But you can see the progress here, and also you can see in the CloudFormation. If I go to the CloudFormation, so I open the CloudFormation here. You can see there are two new CloudFormation stacks created, and you can see the progress from there as well. So here, if you see the latest things, here it is. You see there's a new CloudFormation template in progress. It's been already started, and then it will be when it's done, it will create another one for creating the node groups. So let's refresh this page, and you see there is a new cluster has been created. The name is just a kind of random words with the numbers. The Kubernetes version 1.2.3 provided EKS. If you go to the details, you will see a lot of things here. You go to the compute, there is no nodes and node groups are there because once you create the cluster, then the node groups will be created. So also here, if you refresh, we see that these things are being created. If you go to the details, then I can show you what are the resources have been created. You see plenty of resources created. They created VPC, then they created NAT instances, NAT gateway, blah, 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 all those things. If you have to do it manually, it's a nightmare. I'm not sure how you can create all those things manually with keeping all the settings same. I highly recommend not to use manual process to create all those things, but use EKS CTL to create those things. So, and there are a lot of manifest files. Just browse those examples and choose the one that you have to that suits best requirements. So you can actually go like spot instances and then change those instance type like T3 small and T3 medium, maybe T3 large. That's it. So you have these options to modify this, fork this repo, modify this, and then use this template to create new cluster. Also change the region based on your region. It should be different one. These are just parameters that you can change. So let's come back here. Let's see what is our current situation. It is still being created. That's good. Here you can see it is still being created. That's good. We can also see the progress here as well. It is still in a process of creation. This takes some time. If you have nothing to do, just grab a cup of coffee or tea and come back in 5 minutes later. Meanwhile, I describe what it's doing in the background. So it is creating all those necessary things. So it is creating VPC. So by default, a default VPC is created, but that is not suggested to use for EKS Kubernetes cluster. I highly recommend you to, even if you do it manually, you should create a separate VPC with a public subnet, private subnet, and a NAT gateway to connect those private subnets to the internet. So this is the standard recommendation for creating new cluster in AWS. And also, if you have seen, there are creating IAM roles as well, probably. Let me refresh. So yes, there's creating Elastic IP. This is like Elastic IP is created. This is for the NAT gateway. So NAT gateway requires an Elastic IP. Then it is creating the control plane. That is the EKS cluster. So that is actually taking most of the time. There IAM policy. So there it is. Then you have EC2 root tables. You have subnets. There's IAM role, the service role. There is EC2 subnet. So all those things are automatically created for you. Let me come here. It is still progressing. You can see the progress here. You can see the progress in the CloudFormation template or into this screen. Okay, it's still not done yet. So let me talk with you something else. Once this process is done, so you can CTL, it will, then you can deploy your applications using kubectl. So by default, AWS Cloud Shell automatically have your kubectl installed. So you don't need to install it. It's already there. You just need to configure it. So how do you configure kubectl? The process of configuring kubectl is pretty simple. I'm just writing it before to the notepad. So you can also write it here. The command is kubectl, then, sorry, not kubectl, actually AWS EKS update kubeconfig, and then we need to define region. Here it's US East 1. If you are using a different region, just change the value. Then cluster name, and I'm just going to copy the cluster name, which is this one. So that's it. If you run this command in your Cloud Shell, it should be automatically configured your EKS cluster and do the authentication with this Cloud Shell. Then you can run your kubectl, get pods, get services, all these commands easily. Quite interesting to use these processes. I have found this is very useful, and it saves a lot of your time manually creating all those things, all those blah, blah, blah. IAM role, VPC, permissions. My head spins up when I see all those things. And always do something wrong. Maybe I have created a public subnet, not private. Or maybe there is all public, there is all private, no public. I haven't maybe assigned NAT gateway. So that is also an issue. So I am still checking. Let's see. You can actually fast forward to the next this video when it will be done. So actually I can pause the video for a few seconds. Okay, it was, I think, 5 minutes. So it was good to pause the video. Now everything is done. If you see, all those things are checked. And if you go to the CloudFormation template, you will also see here that everything has been finished. I refresh this screen. This is for the main cluster creation CloudFormation template, and this is for the node group creation. So if you go to this section, which was later created, you go to the resources, you see they have created like IAM role that's required for the node group to access the cluster. They have created a node group and launch template, and using that launch template, they have launched 2 templates. If I go to the details of the cluster, I will be able to go to see that the instances has been created. Actually, the nodes have been created. This is the node group, desired capacity 2, and currently it's running 2. And if you see, instance type is M3 large. Now, if you don't need M3 large, that's okay. You can actually delete that. And what you can do is like create a new node group and like ng small. Select the IAM role. Try to use the IAM role that has been used by this cluster. So you see, rural outfit. If you choose the other ones, it might cause some issues. So this has been created by the EKS CTL, and use this to avoid any sort of issues. Otherwise, you might face some issues, that is your node group is not able to connect to your cluster. So keep everything as default. And here is the spot one. And T3 medium, if you wanted to switch to T3 small, that is also fine, but I suggest use T3 medium, that is quite suitable. Desired capacity to minimum capacity to maximum capacity to. It's up to you. Play with this, whatever based on your requirements. So that's okay. The only thing that here is different is the spot instance. So this will reduce your cost significantly. Click next, click next. You don't need to change anything. Click create. So now you have created one node group manually. So you will see that your instances will come up here. You will see this is a green tick mark here as well. Once this is green, you can actually delete the previous one and get rid of this MG5 larges. But if you need MG5 large, then you don't need to follow. Create a second. Okay, that's just I wanted to show you. So next, I'm going to go to my Cloud Shell and clear my screen. Try to run this command. So that's pretty much it to update the kube config. Here it says that edit new context and blah, blah, blah to home Cloud Shell user kube config. Okay. Now if I can run kubectl, get pods and into all namespaces. And here we'll see we have running pods. So these are basically kube system code DNS proxy. So you don't need to know what is this actually done. It's actually done by it's been created by the kube system. It's required by the kubectl master to run all those things. So what we can do here, we can create some dummy applications, right? And let's assume that I'm going to run some sample applications to run here. How can we do that? There are many ways we can use some sample applications available. Use this over there. If you don't have any sample applications, just create a YAML file. So I'm going to show you some sample applications. Sample apps to run inside Kubernetes. You might see a lot of applications and perhaps on your first step on Kubernetes. I need to know if there is any GitHub repo. Let's search GitHub. So let's see sample apps. Let's go here. I trust DigitalOceans because they are quite well known. Booking, for example, deploy booking for sample application. Let's see. What is this? Booking for sample application. Git clone. Okay, just copy this command. I'm going to go to particular folder. I understood. So you might have checked out this repo and let's see ls what is here. There are booking, for example, docs example, a lot of things here. So I'm going to run this part, kubectl apply booking for .customize. So let's try to run it. Okay, blah, looks nice. They created a namespace They created service account, they have created a service, they've deployed all those things. Now what's next? So that's good. Get all into book info namespace. So this command will show us everything that is running at this moment under the book info namespace. That's good. There is pods, there is services.